Okay, so we can start today's session. So today we are gonna continue with the stuff that we have seen yesterday. Mostly like yesterday we have discussed about the action server client in C++, and today we are going to see the implementation of action server and client in Python. And then we will be seeing how to implement custom messages and service, and also like custom actions if we have time. So this is a plan, guys. So let's start with the action server client using Python. Okay. So the tutorial is here. Basically what I'm doing is I'm just going through it and discussing. Okay, so they have given the code for action server and yeah, action client basically. Yeah, both codes are given. So you can either put this code in a ROS 2 Python package. Okay, in this tutorial they actually running this package, running this node using simply like Python space that package, program name. That is also fine. Okay, so you can able to run it. So if you check the action server implementation in Python, it looks simple, right? It's not that complicated. If you compare other concept like service or any other concept in ROS, Python implementation looks simple. Okay, so that is same for actions. So this is the action server. The purpose of this code is the same as the C++ code, but when you check the C++ code, I mean it's a very lengthy code. You can see here src action. So it's like 102 lines of code. Here it's like 20 lines of code or something. So it's a big difference. So what I'm doing is I'm not creating a package or something. I'm just putting this code in the home folder, or like in the workspace maybe. I'm just opening I'm just opening the gedit, and after that I'm just giving the name as Fibonacci action server.py. Fine, we got the file here, and I'm just copy pasting this line, this code. Okay, so we have the server, and now we have the client here. So I'm also just putting the code in the same path. So we have the action client.py. Okay. So this is a code. This is a code that we are copy pasting. Okay. So we have both the code. Now I'm just changing the permission of each code. That is not mandatory, but yeah, can do that. Wait. So chmod +x Fibonacci action server.py, Fibonacci action client.py. Okay, and we have the code here, and now we can simply execute it. Python 3 Fibonacci action server and Python 3 Fibonacci action client. So it's doing the same job, like yeah, I think it's executing the goal, and states are not set. There are some warnings that we are getting. Let's see what is going on. Action server and action client. The expected result is this. I mean the same data that we got from the C++. So let me try again if there is any change. Okay, action server, and let me check the list of actions. Yeah, there is Fibonacci action is available. Now I can run the client. It's showing goal states are not set, assuming aborted. I'm not sure the error, but we can check if there is any problem in running. Okay, first I was just making sure the code will run or not, just to make sure. Just a second. I'm just comparing the code that we have copy pasted is the same. Client, yeah, it's the same thing. I think it's the same. Let me just try again. Okay. I think there is some issues in the code. I don't know the documentation having bugs. I mean the code that is mentioned in the documentation having bugs. Anyway, we have to check it. Maybe, but we can just go through the code, how they prototype this code. Let me do one thing. Before that, I just want to check this is correct or not. 1 second. Okay, I think this can try. I mean, we can try this as well. Yeah, so the code that we have copied was different actually. So this is actually working. Like I think the goal that the client sending is 10, and we are getting the Fibonacci the series up to 10. Okay, so we can simply go through the code. The concept is the same, but the representation or like the implementation will be different. So if you check the rows node in Python before, like the node is in the form of a class. Okay, the node implementation is in the form of a class. For the action server, it is inheriting from the node class, and we are creating the action server here. The name of the action server is Fibonacci. I mean, the action name is Fibonacci. And then whenever the action server call, then it will be executing the goal. Okay, it will be executing the goal, and inside the execute callback, it is actually computing the Fibonacci and then publishing the feedback as well as goal. Okay, after computing everything, it will be publishing the result. So this is the same template that we have seen in C++. In Python, it is actually very simple. Okay, and in the client, the same concept. There is a class which is inheriting from the node class, and then inside the constructor of the class, we are creating an action client, and the name of the action client, I mean the action is Fibonacci. And then what happening is that after creating the object of this class, we are calling send goal function inside this class. this function. So send goal is simply sending the goal to the server. Okay, so this is the function that is calling the server. Okay, and then whenever there is a response, okay, from the server, this callback will be calling. Okay, and yeah, so that is what happening. I think they didn't handle the feedback in this code, but mainly they have mainly yeah, I think it is only printing the result, and also there is a goal response, like if the goal is accepted or rejected, it will be showing the message here. Okay, so these are the implementation in the client. Okay, so both, if you compare the C++ and Python, the logic is the same. Okay, and if you want to quickly prototype a ROS to action server or client, I will say Python will be better. Okay, because less time to prototype. Okay, yeah, so I hope you got some idea about the action server implementation in Python. It's the same logic. Everything, if you already see the ROS to service, ROS to topic implementation, in it's the same thing that is happening for the actions. Okay, yeah, so yeah, so that is what happening, and they already showing this command to send the goal through command line, which is very useful sometime. For example, we are running the action server, and then if you want to send the goal through command prompt, we can use ROS to action send goal. Okay, so Fibonacci is the name of the action. Then we have to mention what type of action is this. Okay, so the Fibonacci is action tutorial interface / action / Fibonacci. Okay, that is a type of action. Okay, we are saying ROS message type, ROS service type, and ROS action type, right? So this is the action type. Okay, and we can send the goal, which is the order is 5. So if you send it, then we will get the the feedback and also the final result. Okay, so the ROS to action goal send goal is actually when we run this command, it's actually executing a code. Okay, actually executing a node. So that node is taking care of the feedback, then the results. Okay, yes. So that is an idea about the action server and client implementation in C++ and Python. Now we can see how we can write custom messages, services, and action in ROS2, which is very important because in most of the in most of the application, we can't rely on the standard messages. Okay, like we have standard messages, string, int, all these things, right? But some point of time, like for creating a service or creating a action, we may need to write custom service and actions mainly. Okay, so that is what we are going to see next. Okay, so how to create custom messages. Okay, we are going with the tutorial. Okay, yes, so first we are creating a package for keeping some custom messages, service, and action. After that, we are building this package and then we are writing some code by using the custom messages. Okay, so I'm just quickly going through the instruction. First, we are creating a package called tutorial interfaces. Okay, tutorial interface. Maybe what we can do is just check whether this tutorial interface package is already installed. Okay, let's see whether it is in the slash opt. No, it's only here. That is good. And inside this package, okay, inside this package, we are going to create custom messages and service, right? So we are just creating a folder called MSG and SRV for keeping our custom message and services. Okay, so that is done. So now what we are going to do is we are creating some custom messages. So just go to the MSG folder and creating a file called num.msg. Okay, and inside that, so this is our custom message. Okay, inside that we are creating a custom data, which is an integer. Okay, so we have num.msg. Okay, so now we are creating another message called sphere.msg. Okay, sphere.msg. Fine. And inside that we are using, like, for a sphere, it need a center, right? Center point. So center, and also a radius. Okay, so center, then the radius. Okay, so this is what inside the sphere MSG. Okay, right. So we have two messages, num.msg and sphere.msg. Okay, now we are going to create some SRV, service definition. SRV. So the name is add 3int. Okay, add 3ints. That is the name of the service. Add 3ints, and the request part, we have 3 variables. C. Okay, so these 3 variables we need to add. Okay, and okay, so we created, and now what we have to do is, the next step is the important one. We have created the SRV and the MSG. Okay, so basically these are like just static files, right? There is nothing in it. We are just defining. So in order to convert these MSG SRV into corresponding Python and C++ code, okay, then only we can use these messages in our C++ code. Basically what happening is that these MSG, SRV and action is converting to corresponding C++ and Python code. Okay, so that is what we are going to do. So inside the CMake list, we have to add some command. Okay, some command means some lines of code. So that is helping this package to build or to convert the rows messages, rows SRV into C++. Okay, so let's see how to do that. Okay, so we are going to convert these things into C++. Okay, C++ and Python. So first we have to make some changes in the package.xml. Like we have to add some dependency because in our messages we have used geometry messages. Okay, we have used geometry message. For example, if you check sphere.msg, we have been using the geometry messages. So we have to add this as a dependency. And next thing is the important part. Okay, which next thing is the important part. This dependency, okay, this dependency, that is rows ideal default generator, rows ideal default runtime, rows ideal interface package. Okay, this will be converting. These are the main packages that we require to convert the MSG SRV action files into C++ code. Okay, so these are the important packages. Okay, so we have added the dependency, and now it's a time to change the CMake. Okay, obviously we have to add the geometry messages in the dependency. Okay, and we also need to add this one, which is rows ideal default generator. This is again an important package. After that, we can add this line. Okay, so this line, which is rows ideal generate interface, is what converting the num messages, sphere messages, and other SRV into corresponding C++ files. Okay, so this is what the line which is doing the job basically. So you may have seen like compiling the C++ code into executable, right? So corresponding to that, if you want to add the custom messages, or if you want to generate the C++ and Python code from these custom message, this is the line. Okay, so this is the line which is doing the job. Fine. So that's it. These are the main thing that we have to do. Once we are done, then we can do the callcon build. Okay, so we can do the selective build. Okay, as we mentioned yesterday. So callcon build, package select, tutorial interfaces. Okay, this is a package that we are going to build actually. So it actually is showing find package called. So let me see the error. There is an error coming on the CMake 9. Yeah, 1 second. So the error, let me have a look. Okay, so maybe we can comment this out. And let me try again. Yeah, so we don't need the amend CMake. So this is the final the CMake file. So I think it's built properly. Okay, hope we have converted the MSC file into corresponding CPP file. Okay, so in order to check that, we can go to let me see. One second. Tutorial, what was the package name? Tutorial interface. Yeah, so inside the install folder you can see the header files. See, these are the header files generated. So num, then sphere, all these header files got generated, and the srv add 3ins also got generated. Okay, so this is what this conversion means. Okay, this is the Python corresponding module. Okay, so the this package actually converted the MSC file into C++ and Python equivalent. Okay, then we can use the code in this message type in your code. Okay, so that is what showing next. Okay, before that we can see we can use these commands, which is very useful. Like if you want to check what is inside in a particular message type, you can use rows to interface. Okay, rows to interface show the name of the message type. Okay, message type here there is a num message, right? So which is inside tutorial interface. So tutorial interface /msc/num. So this got so what is inside this num message? It is int64 num. Okay, that is actually showing here. Tutorial interface msc num.msc. Okay, and you can also check the sphere. So in the sphere you can see there is a geometry point center and also the radius. Okay, so here there is a testing code. Okay, I'm actually showing it with maybe I can simply show to you the custom message is used like this. Okay, tutorial interface /msc/num.spp. Okay, this is how we can use this custom message, and then this is how we can create the object of the message. Okay, here in Python we can import like this from tutorial interface.msc import num. Okay, maybe we can have a try maybe using the Python, so you can quickly quickly check it. So I'm just creating a Python node, just copy pasting. Maybe I can custom message python pub. Okay, it's a publisher it seems. Okay, oh, it was a subscriber. Fine. So I will change the name. 1 second. Yeah, sub. Okay, so now now I'm creating the publisher. Publisher is here. Okay, so it's also using num, and let's start the publisher and subscriber. Custom message pub. Yeah, it's publishing, and custom message sub, it is subscribing. We can check the topic, rows to topic list. So there is a topic named topic itself, rows to topic info topic. You can see the type of message that we are using is tutorial interface message num. Okay, So this is how we can create publisher, subscriber, or service uh, with a new service type or message type. Okay, this is an example for a custom service that we have created. Okay, this is like adding 3 numbers, okay, using the custom service. Okay, so yeah, so I think we have discussed the custom message, and then there is a custom action as well. Okay, implementing custom interfaces, which is actually the same. Yeah, it's almost the same. Yeah, there is a big example mentioned here with it's not action, but an example with the custom message. Okay, yeah, this is what the creation of action. That is also the same procedure. If we have the action file with us, then just include in the rows ideal generator, which is inside the CMake file. So creation of message, service, action is following the same way. Okay, there is no difference. Only thing is maybe I can add these things so you will get an idea. So the action name is Fibonacci.action. Okay, so what I'm doing is I'm just going to the same package. I'm creating a folder called action. Okay, I think action will be good. Let me check. Yeah, action. Now inside this I'm just creating the new action, Fibonacci action. Okay, now this is the action template. Like first is the request, second is the feedback, and second is the result, and third is the feedback. Okay, and I'm just copy pasting. So we have the Fibonacci.action here, and then I'm going to add this file to the CMake. Okay, that is only the thing that we have to add here. Okay, so you can see here we can simply copy this line. Okay, that's it, and then just do the call con build. Where is it? I'm lazy to enter the full command, but if we have this time then we can, yeah, anyway, call con build package select tutorial interface, I think. Tutorial interface. 1 second. Okay, packages select, yeah. So we are building the tutorial interface with the new action. So it's actually building. Okay, so it's got build, and if you check the install folder, then tutorial interface, you can check the new folder called action, and this is the header file. Okay, so the same method, the same package that that we are using to create MSG, then SRV and action. Okay, so these are the main thing that we have planned to discuss, and maybe I can discuss one more small topic. After that we can conclude today's session. So the last topic is a small one, but I think it will be useful. Let me take the tutorial again. Okay, the tutorial is this one: monitoring for parameter changes. Okay, parameter changes. So what is this tutorial about? Okay, the tutorial is for it's a very useful one. The tutorial is about creating a node. Okay, and it is declaring a parameter. Okay, so if you set that parameter, this node will be calling a callback. Okay, node will be calling a callback. So I think let me see if this thing is already present in the tutorial, so that I can simply execute it. No, I guess, yeah, the package is not present. Maybe I can simply show the code, and you can check it. It's simply the parameter. We already discussed how to write a parameter. Okay, how to write, how to get a parameter, how to set a parameter, all these things. The main difference here is you can check the code. This is a C++ code. Everything is same. Like if you check a normal ROS2 node, it's almost the same. In the parameter code, what happening is that we are declaring a parameter called an int param. Okay, and by default value it is 0. Okay, and what happening is that we are creating a handle. Okay, we are creating a handle for creating a callback. Okay, so that is the main difference. You can see here we are creating a parameter subscriber. Okay, the main purpose of the parameter subscriber is whenever if there is any change in the parameter, it will be calling the callback. Okay, the callback is like mentioned here. Okay, this is a new way of writing a function in C++, new version of C++. So whenever there is a change in the parameter, this CB, okay, meaning this much of section will be executing. Okay, so the callback is basically printing the value. Okay, that is what happening. Whenever we change, this callback will be executing. So what is the purpose of this callback? I think I already explained in the previous class. It is basically for for dynamic reconfiguring, meaning when you change the parameter, it will be changed instantaneously. Maybe I can show you a last example and then we can conclude. I'm just showing the turtle sim simulation. Turtle sim. Okay, so the turtle sim is having the background color as blue, right? But actually that color is set as a parameter. Okay, so we can change those parameters. Okay, we can change those parameters and see what happen. Okay, what will happen. So in order to check the parameters, you can use ROS2 parameter list. Okay, and second, yeah, so you can see the turtle sim, which is this this node, is having this much of parameter. Okay, BGR, which is the background color, So we can able to set the parameters like rows to param set, then turtle sim, okay, then 1 second, the parameter name and the value. Okay, so I'm setting the blue version, blue component of this parameter as 0. Okay, so you can see instantaneously the color change. And if I'm setting the parameter red as 0, it again changed to greens. Okay, now I'm just changing green, and all the components BGR got 0 and it's black. So if I am putting G as 255, it's red, it's completely green. If it is red, it went yellow. And if I am putting the blue as 255, it's got white. So 255, the maximum value is 255. So if all the values are high, then it's turned white. So this is what the use of parameter callback in TurtleSim. They implemented the parameter callback. Okay, so I think we can conclude today's session. Okay, so if you have any question related to these topics, you can ask. Otherwise, we can conclude the session today. Okay. So Kasim, do you have any question related to the topics that we have discussed?
No, sir. Everything has been well. Thank you.
Okay. So we can conclude today's session, and after that we can continue discussion. Okay. So let me conclude 1 second.